Good morning, all of you. Let us recollect the important areas in the form of questions that we already discussed in the last session. That is the form of question. First one, take down this question. Differentiate adsorption and absorption. Second question, list the major difference between physisorption and chemisorption. How does temperature affect the rate of adsorption? Draw the adsorption isobar for physisorption and chemisorption. Physisorption and chemisorption. Process in which both adsorption and absorption takes place is called dash. Process in which both absorption and adsorption takes place is called dash. And next question, that is, write the expression for Freundlich adsorption isotherm. Freundlich adsorption isotherm. Draw a graph between log x by m versus log p. Log x by m versus log p. How will you find out? The value of K and N? K and N. Write the seventh one. Write the important application of adsorption, or what are the major application of adsorption. These are the main questions usually asked for the examination from the part adsorption. Next is explain the following terms. I think it is ninth one. Explain the following terms. First one, catalytic promoter and inhibitor. Catalytic promoter and inhibitor. Second one, activity and selectivity of catalyst, activity and selectivity of catalyst. Explain the adsorption theory of heterogeneous catalysis. Adsorption theory of heterogeneous catalysis. Next one, differentiates homogeneous and heterogeneous catalysis. Homogeneous and heterogeneous catalysis with suitable example. Homogeneous and heterogeneous catalysis with a suitable example. And try to write the answer for these questions. And in the next session, we discuss about shape selective catalysis. Shape selective catalysis. Shape selective catalysis are mainly done by zeolite. You know what are zeolites? For last year in P block element you have studied about silicate. Silicate having the basic structural unit of SiO4 4- tetrahedral unit. All silicate contains this basic unit. Actually zeolites are sodium aluminum silicate. Sodium aluminum silicate. And you have studied that zeolites are used as an inorganic ion exchanger for the removal of hardness of water under the name permuted method. That is sodium aluminum. Sodium is monovalent, aluminum is trivalent. That is, altogether there are 4 unit positive charge, here also 4 negative charge. Hence, it becomes when it becomes zeolite, we can represent it as NaAlSiO4. That is sodium aluminum silicate. Actually, they exist as Na2Al2Si2O8.XH2O. These zeolites have honeycomb structure. They have microporous cavities in them with the dimension actually 260 to 740 picometer. And the main catalytic activity of zeolite is due to the structure or due to the presence of cavities present in them. Such a catalysis is called a shape selective catalysis. Zeolite act as a catalyst due to the presence of large number of cavities or holes present in the microporous. Picometer means into 10 raised to minus 12 meter. Microporous cavities, so that they act as a catalyst. Such a catalysis is called a shape selective catalysis. One such zeolite, namely ZSM5. Zeolite selective catalysis having microporosity 5. ZSM5 is used for the conversion of alcohol to petrol or gasoline. Alcohol to petrol. That's about this shape selective catalysis. Next topic is about enzyme catalysis. Enzyme catalysis. Already we have studied about this catalyst which involves reaction various industrial process. You know, in our body, when we eat food, the process digestion takes place by using lot of enzymes, the anabolic as well as catabolic, together known as metabolic activities in living organisms, are catalyzed by the presence of a biomolecule which is called enzymes. Or in other words, enzymes are biological catalysts. Biological catalyst. They catalyze the reaction takes place in living organism, and all enzymes are proteins. The activity of enzyme catalysis is explained on the basis of lock and key model or lock and key mechanism. According to this model, lock and key. A particular key can open a lock in the same way. Each enzyme can bind with or attach with a particular substrate molecule to form enzyme substrate complex. Enzyme act on a particular substrate, form enzyme substrate complex. This enzyme substrate complex then changes to enzyme product complex, and finally enzyme is regenerated without any change. That is why they are called biological catalysts. They enhance the rate of a reaction without undergoing a self change. That is the mechanism commonly called a lock and key model or lock and key mechanism. Each enzyme can bind with a particular substrate molecule. That reveals the specific nature of enzyme. Not all enzyme can act on all sites of. That is, a particular enzyme can bind with a particular substrate molecule. Then, what are the characteristics of enzyme catalysis? Enzyme catalysis. What are the characteristics? Characteristics of enzyme catalysis. First one is high efficiency. High efficiency means enzyme as a catalyst can increase the rate of a reaction up to 10 million times faster. 10 million times faster than uncatalyzed reaction. As a catalyst, enzyme can speed up the rate of a reaction up to 10 million times faster than uncatalyzed reaction. Here the scientist gives an example as, suppose, when we chew our food, the salivary amylase, that is ptyalin, helps in digestion. When that food reaches intestine, there is another enzyme, pepsin, is present in gastric juice, and after completing the digestion, the digested food is absorbed by the wall of small intestine. Suppose no enzyme is produced in our body, it will take nearly 50 years for the digestion of carbohydrate. Another biomolecule, carbohydrate digestion will take place after 50 years, or 50 years is required for the digestion. We mainly consume this carbohydrate food, and once we take that food, the digestion will be completed after 50 years if there is no enzyme, if no enzyme is synthesized in our body. Then optimum temperature and pH. pH neutral medium, temperature 310 Kelvin. The enzyme activity is more in at a particular temperature and a neutral medium. Then enzymes are highly specific in nature. Enzymes are highly specific. The specificity, during fermentation process, fermentation means the degradation or decomposition of complex organic molecule into simple unit in presence of biological catalyst or enzymes. Sucrose having the formula C12H22O11 plus H2O. Here an enzyme called invertase hydrolyze sucrose into glucose and fructose. Another enzyme, cymase C6H12O6, gives, in presence of cymase, it gives C2H5OH plus CO2, ethyl alcohol, degradation of complex organic molecule into simple unit in presence of biological catalyst. That is an example of fermentation process. You know, instead of invertase, if we use cymase, this reaction does not carry out. Only invertase can convert or invertase can hydrolyze sucrose into glucose and fructose. And also, invertase is not able to convert this glucose into ethyl alcohol and carbon dioxide. Only cymase can do that. That reveals the specificity or specific action of enzymes. That is the third characteristics. And fourth one is, I already told that all enzymes are protein. Normally, the catalytic activity of enzymes speed up in presence of a non-protein part, which is called a cofactor. Non-protein part called a cofactor is there to enhance the rate of or activity of enzymes. And the continuation questions, that is, explain shape selective catalysis. Shape selective catalysis. Dash is used for the conversion of alcohol to petrol. What are enzymes? Explain the mechanism. Explain the mechanism of enzyme catalysis. Also give the characteristics, or what are the important characteristics of enzyme catalysis. Okay, explain shape selective catalysis. Question is from the topic that we already discussed now. Okay, and that second topic of this lesson is already over, that is about catalysis. And third topic, that is very important one, that is colloids. Colloid. And colloid is a state of system. You know, when sugar or sodium chloride is shaken with water, when sodium chloride is shaken with water, we get a homogeneous system. We get a homogeneous system. That homogeneous system is called a true solution. Is called a solution or true solution. Size of true solution particle is less than 1 nanometer or 10 angstrom unit. 1 nanometer. Size of true solution particle is less than 1 nanometer. And precipitate. When a precipitate normally it is a solid phase separate from a solution. When silver nitrate and sodium chloride are allowed to mix, immediately you get a white curdy precipitate of AgCl. That solid phase separate from a solution is called a precipitate. When that precipitate is treated with water, the system formed is it homogeneous? No, it is a heterogeneous system. Heterogeneous system, because there are two distinct phases, solid as well as liquid. That heterogeneous system formed is called a suspension. It is called a suspension. Suspended particle has size. Size of suspended particle is greater than 1000 nanometer. Greater than 1000 nanometer. In between this, that means the particle having size between 1 to 1000 nanometer, size of particle having 1 to 1000 nanometer, there is a heterogeneous system. A heterogeneous system in which the particle size lies between 1 to 1000 nanometer is called a colloid. Is called a colloid. A colloid is a heterogeneous system in which a substance is dispersed. A substance is dispersed in the form of very small particle with the dimension 1 to 1000 nanometer in another medium. The substance which is dispersed in the form of very small particle is called a dispersed phase, and the medium in which that substance is dispersed is called a dispersion medium. Clear? From the size of the particle, it is obvious, it is very clear that the colloidal particles lies in between that of a true solution and a suspension. It is a heterogeneous system. It consists of dispersed phase as well as dispersion medium. Dispersed phase means the substance which is dispersed in the form of very small particle whose size is in between 1 to 1000 nanometer. And a dispersion medium means the medium in which that substance is dispersed. And examples for this naturally occurring colloidal systems are blood, muddy water, ink, rubber latex, etc. Blood, rubber, latex, muddy water, milk, all these are examples for this naturally occurring colloidal system. Next is how these colloids are classified. How colloids are classified, that is classification of colloid. Classification of colloid. First classification, first criteria for the classification is based on the physical state. Physical state of dispersed phase and dispersion medium. Dispersed phase depending upon the nature or physical state of dispersed phase and dispersion medium, how these colloids are classified. These colloids are sometimes represented as Sol, not S-O-U-L, Sol, S-O-L simply. How colloids are classified based on the physical state of dispersed phase and dispersion medium. And here, first column about dispersed phase, second one dispersion medium, third one name of the system, fourth one the example. What about the physical state of dispersed phase and medium? Different types of colloidal systems are formed and we can cite respective example for each system. First one, solids. Both the dispersed phase and dispersion mediums are solid. Don't confuse with the classification in solution. Here solution is a homogeneous while colloid is a heterogeneous. Here first classification is done on the basis of physical state of dispersed phase and medium. Based on the solid, both the dispersed phase and dispersion mediums are solid. The system is called solid sol. It is called solid sol. And name of system is solid sol and example is colored glass. Colored glass. You know, glass mainly contains sodium carbonate. Certain blue colored glass, cobalt salt is added. Two distinct phase, colored glass and certain birthstones, gems. Next, solid dispersed in liquid. Solid dispersed in liquid, that heterogeneous system is called a sol. Here starch sol, colloidal solution, gold sol, ferric hydroxide sol, arsenic sulfide sol, etc. Solid dispersed in gas. Solid in the form of very small particle 1 to 1000 nanometer is dispersed in a gas, so that which leads to the formation of a heterogeneous system. That system is named as aerosol. It is called aerosol. Example, common example is smoke. You know, smoke means carbon and dust particles which are in solid state dispersed in air. That is called aerosol. Next, liquid solid. Liquid dispersed in solid, that system is called gel. Example, butter, cheese, etc. Hair cream, all gel. Liquid dispersed in liquid. Liquid in liquid, both dispersed phase and mediums are liquid. That system is called emulsion. Emulsion we discuss in detail later. There are two types of emulsion and here we cite example for each type. Examples for emulsion, one is milk and other is cod liver oil. Fish oil, shark oil, cod liver oil. Okay, next type, liquid dispersed in gas. Liquid dispersed in gas, that system is called liquid aerosol. Liquid aerosol, example cloud. You know cloud, water droplets dispersed in air. That is called a liquid aerosol. Next category, gas dispersed in solid. That system is called a solid form. Solid form. Example, foam rubber, rubber foam, foam rubber, or a soft type stone, that is pumic stone. Gas in liquid, that system is called foam. Example, soap foam, foam or froth. Here you can see that there are three types of solid, three types based on solid, liquid, and only two in the case of gas. And the next type of classification is usually gas in gas. You know, gas in gas is a homogeneous system. Here colloid is a heterogeneous system. So only 8 groups are there. 8 type of classification based on the physical state of dispersed phase and dispersion medium. There is no colloidal system in which gas dispersed in gas. They form homogeneous, colloid is heterogeneous system. And normally one more question asked from this table. You study the table thoroughly. For example, while eating bread using butter, when you are eating bread using butter, one of them realized that butter is a colloidal system, or butter belongs to the class of colloid, and identify or which is the dispersed phase in butter. Now it is easy to answer because all the things are represented in this board. Or for the entrance examination, they give 2 or 3 options and find out the incorrect statement. One example is the system, colloidal system formed by liquid in liquid is called the gel. One of the example, that is actually liquid dispersed in liquid is called emulsion, not gel. Question asks which is the incorrect statement, so that you study the table thoroughly. This is the first type of classification based on the physical state of dispersed phase and dispersion medium. Okay. Next, second type of classification we discuss in the next class. Okay. Thank you all.